Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video, we will be starting our next boosting algorithm. Till so far, if you remember, we have already covered up about how the working of AdaBoost algorithm works, right? Adaptive boosting algorithm. We have seen the core idea behind the weights part. How can we update that? What's the mathematical intuition behind that? And what is the internal working of any boosting algorithm? What is the core idea behind combining all the weak learners to get the strong learner altogether, right? So in this specific video, the idea will remain same because gradient boosting is also a part of a boosting algorithms, but the core mathematics will get changed. So specifically in today's session, we will be focusing on that how this gradient boosting will be helping us to solve any regression problem. Again, let me repeat that point that whenever we will be having as a target variable the continuous values which we want to predict, that is where we are calling it as a regression problem, right? So let's try to understand today in this specific session that what's the maths behind the same, how basically my gradient boosting algorithm will help me to understand the regression part, to understand the predictions of a new test set data that we have. So now let's focus on the mathematical part of gradient boosting. And for that, I have taken one table where you can see there are dummy records that we have. Specifically, the 5 number of records I have picked up randomly. So here you can see first record, second record, third record, fourth one, and the fifth one. Now you can clearly see that we have two features available in our data, which is feature F1 named as intelligence level and feature F2 named as score. You can consider that these are the 5 records of the people that we have, for which we have two important features of that employees. One is the intelligence level of that employee, another one is the score, like how they are working in the company, what is their rating, and so on. So depending upon that, let's say out of 10, they have a score of 8 rating, 7 rating, 6, 9, and 5, and this is their intelligence level. Now depending upon their intelligence level plus the score of their working, they have a package. Someone is having a package of 3 LPA. So this is like, let's suppose this is in a lakh per annum. So let's suppose the first employee is having a package of 3 LPA. Second one is having a package of 4 LPA. Third one is having a package of 8. And fourth one is 6. And the last one is 3. Now you can clearly see that what we want at the end of the day. Let's say if, let's suppose I have a problem statement where I'm saying that can you do let me know if, let's say, the intelligence level of a new employee which is coming in the industry or in the company, having a 115, and let's say the after seeing his 6 months performance, his score is coming out by manager as, let's say, you can say maybe 7. So what is the expected salary or the package? Maybe if, let's say, we want to give an increment, so let's suppose they have some salary where he started. Now what should be the expected one? So depending upon these two features, what I want at the end of the day is that my model will be able to give me some number. And you can see that this target number or this target value which we want as a prediction is somehow the continuous values, right? This target number is a, you can say, continuous value. And that is the main reason why it is called as a regression problem. Makes sense? So now this is something which we really want to predict. I hope that before coming to this session of mathematical intuition, you already have covered up my previous session where we have seen the complete mathematical idea about AdaBoost algorithm. In any of these algorithms of boosting, you will observe that somehow sequential learning is going on, right? Means here also you will be able to observe that, let's say, if I will be having 3 models coming together, all of these 3 models, first of all, give me some result. My model will evaluate that, and accordingly, it will give me the further results. If you remember, in our previous discussion of AdaBoost, my model was simply looking into how many number of data points were misclassified and increasing the weights of those misclassified points, so that in the next iteration, my model will give more focus to those specific points. Similar kind of discussion will happen here, but how it is different from that discussion, that is what you have to completely look into it. Okay. target is in the very first part is the package. Now what will happen, what my model M1 will do in the very first iteration, it will just simply take the mean of the complete celery data points that we have. So what it will do is, it will say what is the mean value of 3 plus 4 plus 8 plus 6 plus 3 divided by 5. So you can see we will be having 5 data points available. If you will do the division by 5, this is where you will be able to get the mean value of these 5 data points. So I have already done the discussion, evaluation part, and this is coming out to be, I think, 4.8. So one thing which you will be able to observe, that this model M1 will give the prediction, which is, you can say, y1 cap. It is nothing but is the mean value in the very first iteration. So be it any intelligence level, be it any score, we are not applying any as such machine learning model. It is randomly like giving the average of all the given records that we have as a target. So in all the iterations, you will be able to see that what we are getting as a result is 4.8. So we have 5 records available, and for every specific record, our result is 4.8. Makes sense? Now in the next part, if you will be able to observe, the next part is to evaluate the residuals. Now if you remember our discussion of previous modules where we have discussed about maybe, let's say, linear regression module, in the very first discussion, if you remember, we have talked about this term called as residuals. Do you remember? What is the meaning of residuals? Residuals is nothing but is the difference between what is the actual value minus what is the predicted value. In case of linear regression, we were taking the mean squared error as the residual, where I was doing y minus y cap whole square 1 upon 2, summation of I is equals to 1 to n. It depends on how many number of records that we have. In this case, when we're talking about gradient boosting, the same residuals are called as pseudo residuals. So there is a term called as pseudo residuals. The concept will remain same, that here also we are trying to evaluate the difference between the value of y minus y cap for all the data points that we have. So in this case, we will be having 5 data points available. So what our model will do, it will try to evaluate in the next iteration the value of, you can say, R1, which I'm talking it as a pseudo residuals. Now here the interesting thing will lie. So I'm just removing this thing and I'm writing in the above part this as a regression. And now what I'm trying to do here is I'm trying to evaluate the value of R1. And you know that the value of R1 will come out to be the difference between this target, because this is something which we can say is a y. And this is something which we can say is a y1 cap. So 3 minus 4.8 is negative of 1.8. 4 minus 4.8 is negative of 0.8. 8 minus 4.8 is 3.2. This is 1.2. I already have done the calculation here, so that is why I'm doing it a bit fast. 3 minus 4.8 is negative of 1.8. So in this way, we will be able to get the R1 value. Again, I am repeating, R1 is the difference between your actual value and what your model M1 is predicting. And if you remember, your model M1 is nothing but is the prediction of the mean value. So if let's suppose this is the new test set, new data that my model is getting with an intelligence level of 115 and a score of 7. And if my model is saying that what could be the package of that guy, so my model, if we are just applying M1 model, it will always say 4.8 only. Make sense? Now, this is where actual interesting part comes into picture about the gradient boosting. In the next iteration, definitely we are using multiple models here, right? M1 is a weak learner, so we cannot rely upon that. Now here a stage will come where we are trying to apply a M2 model, right? We are trying to curate a decision tree for the M2 model. Now in this specific case, what will happen is, in that specific decision tree, which you will curate as a M2 model, the interesting thing will be your input features in that decision tree is that will be this F1 and F2, right? Which is nothing but what you have is the intelligence level and the score. But your target feature or target value or target column is nothing but is equals to, you can say, residual R1. And this is one of the interesting point. So in the gradient boosting, always remember that as you progress and you will apply the multiple decision trees or any kind of a algorithm which you want to apply in a machine learning, your next upcoming feature as a target value will be the residual one. So this is something which is the important idea given by the gradient boosting algorithm. So if you will try to refer any of the CNET books, for example, here I am referring Orlin hands-on with machine learning book, you can see this. So what is happening is, instead of tweaking the instance weight, so if you remember in our previous discussion of ADA boost, we were tweaking the weights value and we were saying that, wherever there is a misclassification, let's update those values a bit higher as comparable to the values which we have a correctly classification. So instead of tweaking the instance weights at every iteration like ADA boost does, this method tries to fit the new predictor to the residual errors made by the previous predictor. This is one of the most important line to understand, that whenever you're trying to curate a new model, in that new model, the target prediction is the residual errors which is given by the previous model. So what will happen at the end of the day is how your model will looks like. So here I have tried to train the data on my Colab notebook, and what kind of decision tree I will be able to get, I'm just writing it here. For example, here we are saying intelligence level, if it is less than equals to 105, right, go towards left, otherwise go towards right. Now again the comparison will happen. The intelligence level, if it is less than equals to 95, if it is less than equals to 95, the target is the residual, so it will be negative of 1.8. Otherwise, it will be negative of 0.8. Similarly, here it will be compared with the score value. If it is less than equals to 7.5, the score will come out to be, residual will come out to be 3.2. Otherwise, it will come out to be 1.2. So again, I am repeating this point that here the target, this leaf node value contains the residuals, or you can say predicted residuals, right? That is the core idea behind, you can say, gradient boosting. Makes sense? So now what we can do? What we can do here is, we will be having the value of R1, and now we know what will be the prediction given by the model M2. So that is something which I am writing it as a Y2 cap followed by the decision tree, right? So if you will see the record number 1, what we are saying in this record number 1, we are saying that intelligence level is 90, score is 8. So it will go to the decision tree 1 given by model M1. So this is the decision tree that we have. So what we are saying that intelligence level is 90. So it will go towards left side. Again, it is saying intelligence level is 90. It will go towards again left side. The value will come out to be negative of 1.8. So what is the prediction? It is negative of 1.8. Makes sense? Now it will again move ahead 107. So again, what will happen is less than 105, go towards this. And now we will be having 100. So it will go towards right and the prediction will be negative of 0.8. One thing which you will observe here is that we at every iteration getting that residuals value. Similarly, if you will just keep on doing the evaluation with that decision tree which just now I have created, you will be getting similar values as R1 because that is the main idea to predict. One thing which you will be able to observe is that somehow this model seems to be overfitted. And the main reason could be because the number of data points that we are working as of now in the discussion part today is very, very less. If I will increase the number of data points, obviously that problem will also get resolved. Now what will happen is the next idea is to get the, you can say, final predictions by the model M2. Okay, this is the predictions given by the decision tree. Now if you will ask me that what is the combination of model M1 and M2 entirely together, because it's a boosting algorithm, right? When I'm saying boosting algorithm, it will try to combine the predictions of M1 also and M2 also. So you can ask me a question that, Priya, how we will be able to get a final predictions? So final predictions by the given model YPRED, where it is a combination of M1 and M2, it is M1 plus eta times M2. What is eta? Eta is the learning rate, you can say. Now, we already had a great discussion about this learning rate in the previous part of the ADA boost as well. The similar kind of scenario is available here as well. By default, it is 0.1, and it is basically used to overcome, or you can say reduce, the overfitting in any given model. So it will basically be helpful to reduce the error in the model. So here you can see what is the value of M1, which is the model's prediction given by solely M1 model is 4.8. So what you will do in order to combine these predictions, it will be 4.8 plus eta is 0.1 into what is the model M2 value. It is nothing but is equals to negative of 1.8. So after combining both of these predictions, what we will be able to get is 4.8 minus 0.18. So the final result will come out to be, let me just try to open my calculator. It will be 4.8 minus 0.18. So it is 4.62, if I'm not wrong. Yes, it should be 4.62. So if let's say this is the prediction after combining model M1 plus eta times model M2. So if let's say I'm saying that I'll just use only two models, so my final prediction will be 4.62. Similarly, you can evaluate the predictions of, you can say, other models as well. For example, in next case, it will be again 4.8. So for the second record, it will be again 4.8 plus 0.1 multiplied with, what is the value of M2? It is negative of 0.8, right? It is negative of 0.8. So it will come out to be 4.8 minus 0.08. I have not done this calculation, so maybe let me do it again further. So what is the answer we will be able to get is 4.8 minus 0.08. So the prediction will come out to be 4.72. So this is the prediction given by the second number of record that we have, 4.72. Similarly, let's evaluate the next one. So this is done. Next is 3.2. So definitely for the next record, what you will do is you will again evaluate what is the prediction of model M1. It is nothing but the mean value plus 0.1 into what is the value given by the model third record is 3.2. So it will say 3.2. So what is the answer? 4.8 plus 0.32 if I'm not wrong. And if you will just combine both of them, you will be able to get 4.8 plus 0.32. So it will come out to be 5.12. Similarly, you can just evaluate for the next record that we have. That is the main reason why I have taken only 5 number of records. And you can just try the results at your end also. Might be there will be some calculation mistake. So please at that moment forgive me. This is similar only as the above part. And here this is 4.8 minus 0.12 if I'm not wrong. Let's try to evaluate directly. 4.8 minus 0.12. It is 4.68. 4.68. So one thing which you will be able to observe is that 4.68. I think now it is visible on the screen. So now one thing which you will be able to observe is that here we have pre-assumed again that the learning rate is 0.1. Now what will happen if we will increase this learning rate too much? The impact of this prediction given by a model M2 will be too high, right? And if it is very less, then the impact will be very less. So at the end of the day, it's a hyperparameter which we have to tune very carefully depending upon what kind of data we are dealing with, so that it should not be too high and it should not be too low as well, right? So by default, usually you will see in the various circumstances, the various kind of data sets, it is by default assumed to be 0.1. And that is the main reason I have taken 0.1 also, right? Now let's assume that you will say that Priya, I'm not comfortable with only 2 models. I just want to imply the model M3 on top of this as well. So same discussion will happen for M3 also. Now how the predictions will get changed in that case? So this is the predictions given by, if you're using only 2 estimators. If let's say you are saying that I want to use 3 estimators, you can extend your discussion, right? If let's say you are saying that I want to use 3 estimators to get the final prediction. So what will happen in this case? Your predictions, final predictions will looks like What is the prediction given by model M1 plus eta, which is the learning rate, into model M2 plus again you will apply that eta value into model M3 prediction, and that is the same flow which is going on. So what will happen for the model M3? Again you will try to evaluate the residual R2. Now how basically you will evaluate the residual R2? Again you will try to find out the difference between the actual and the next predicted value that we are getting. So it is 3 minus 4.62. After combination of M1 and M2, the final prediction is 4.62. 3 minus 4.62 is nothing, but it will come out to be negative number minus of I think 1.62. But let's again see this step by step. 4.62. So it will be negative of 1.62, right? Similarly, we will evaluate 4 minus 4.72. So it will be negative of 0.72. Next is 8 minus 5.12. So 8, so let's do that. 8 minus 5.12. This is coming out to be 2.88. Next is 6 minus 4.68. So it is 6 is the actual, 4.68 is the prediction. It is 1.32. And the last one is 3 minus again 4.62. So it will be negative of 1.62. So this is the residual that we will be able to get. Now once we will be able to achieve the residual, what is the next step? Next step is to create a decision tree for model M3. This is for model M2 we have created. Now the next step is to curate a decision tree for model M3. Now in the model M3, your input features, again I am writing, your input features will be the F1 and F2, which is the intelligence level and the score. And your output, or you can say the target feature when you will design this algorithm is the predictions by the previous model. So in this case, our predictions by the previous model, the residuals by the previous model. So it is the residuals of the previous, you can say, predictor, which is nothing. In our case, it is nothing but is equals to R2. So what will happen is again a new decision tree will be designed. Now once you will try to run this code on your Colab notebook, you will be able to see that this is how your tree will looks like. Intelligence level, if it is less than equals to 105, it will go towards the left. Intelligence level less than equals to 95, it will again go towards left and predict negative of 1.62. Otherwise predict negative of 0.72. Here it will be intelligence level less than equals to 7.5. If yes, it will predict the answer as 2.88. Otherwise it will predict 1.32. So one thing which you will be able to observe if you have any sort of confusion in order to curate a decision tree, things are very simple. Decision tree will be created as per the concept that we have covered up in our previous discussions, having a higher information gain or lower gain value. Depending upon that, we are trying to curate a decision tree, or our model will try to curate that. Now, as per this, you can see that this final leaf node values contains the predictions of residual R2, right? Which is the target one. So this is the predictions are this negative of 1.62, negative of 0.72, and you will see that these predictions are approximately similar to the value of R2. So what will happen is you will try to curate the value of Y3 cap from this model M3 predictions. So what is the value of Y3 cap, which you will be able to get now for all these 5 records? You will observe it is approximately exactly similar as the values of the R2 that we will be able to get, which is negative of 1.62, negative of 0.72, 2.88, 1.32, negative of 1.62. How I'm getting that? Again, I'm trying to convey here. For every record, try to pick, for example, 90 and 8. See what is the prediction you will be able to get. 90 and 8. So definitely 90 you will go here. So the residual is coming out to be negative of 1.62. Similarly, you can just check for the other records also, right? And this is the final prediction which is given by your model. If let's say you're trying to now combine all of these predictions by all of these 3 models, M1, M2, M3, what you will do? If let's say you want to see that, what are the predictions of after combining all of these three models of the Y pred, it will be nothing but 4.8, which is the prediction of a given model M1. 4.8 plus 0.1 into what is the value of M2? Just check it out, which is nothing but negative of 1.8. What is the value of M2 is Y2 cap. Negative of 1.8 plus again 0.1. What is the prediction given by model M3? It is nothing but, I think, negative of 1.62, which is the residual of the R2 value, negative of 1.62. So if you will try to solve this particular problem, it will be negative of 0.18, negative of 0.18, negative of 0.162. So this result is approximately coming out to be 4.5. Let's try to verify this thing. We have the value of 4.8 minus 0.18 minus 0.162. Yes, it is approximately, you can say 4.458, right? So this is the final prediction given by our model for the record number 1, right? So you can see that the actual was again 3 and the final is nothing but as 4.458. When we are using the 2 boosters, in that case it was coming out to be 4.62. So you can observe one more interesting thing, that as you are increasing the number of estimators, your results are coming closer to the value 3, which is the actual value that we have. That is the core idea. In general, whenever we are using these models, definitely you will be able to observe that in practical use cases, we are not limited to 3 estimators. By default, it is 50 or 100 depending upon what kind of algorithm you are using. So definitely it will just combine all of these boosters till 100. The main idea is that as you're increasing the number of estimators, the results are more closer towards the value of I. And that is what we want. We want the residuals value to be very, very low, approximately equals to 0. The difference between the actual and the predicted will be approximately equals to 0. So this is how basically. But one thing is, you will just keep on adding with the eta value, keep on multiplying the results, right, to get the final results. So for example, here we are getting the result as 4.45, right? Where we have solved, here we have solved, when we will be trying to evaluate with the 3 estimators. Similarly, you can do a discussion with respect to 4 estimators, 5 estimators, and so on. This discussion will keep on going, but the idea now will remain the same. And I hope that with this session, you will be able to get the idea behind the mathematical part of how the gradient boosting algorithm works. This is the main idea behind this gradient boosting algorithm. One thing which I just want to share with you all is, please do refer this specific book as well, with reading a part of how this algorithm works. You can see that what they are saying is, this is called gradient boosted regression trees. Here you can observe that at every iteration they're showcasing that, for example, you are trying to train a decision tree. Now you will try to evaluate the residual errors, which is nothing but the difference between actual and the prediction by the given model. And what is happening is, in the next iteration, that is the core idea, we are trying to give the value of Y2 as the output. That is the main idea behind this gradient boosting algorithm, that at every iteration what is happening is, it is trying to give the target as the residual of the previous predictor. That is the core idea. And when you're trying to make a final prediction, it is nothing but is the sum of all the predictions that you're getting for a new test set for all the trees that we will be having. Here they are not using that learning rate, but usually it is being used to reduce the overfitting part as well. If you don't want to use, by default this value will become 1 itself. Otherwise it is usually 0.1 only for maximum kind of data points that we will be having, right? So this is the overall idea behind how the gradient boosting algorithm works. Still, if you have any confusion, because we have done a lot of calculations, might be there is any calculation mistakes as well, you can let me know. Otherwise, I believe that the core idea behind this algorithm is pretty much clear to everyone. Now, what I will do is, in the next upcoming session, I will showcase you step-by-step implementation of whatever things we have covered up so far. So that entire journey of understanding the mathematical intuition of this gradient boosting will be pretty much clear to everyone. Bye-bye everyone, and see ya.